equations by elimination easy step-by-step binder lesson. Go ahead, put your name up there. This will be the answer key. So I go by Key West. Put whatever day it is that you're working on this. Today's date, I'm creating this on the 18th. And write whatever period number you're in with me. Just a quick note, you will be showing me these once we get back to school and then clipping them into your step-by-step binder. So this is worth credit, even though it says not homework up here. It's gonna be worth a classwork grade. All right, so solving a system of equations by elimination. In order to solve this system, it used to be we needed a graph and we would have to convert these to slope-intercept form and graph both of them and see where they intersect. But we can do it with just algebra. We can manipulate these two equations in a way that we can figure out a combination of an x and a y value that will make both of them true at the same time. And here's how we can do it with a technique called elimination. So follow along with me. Step one. All right, so in step one, we want to look for a zero pair. Look for a zero pair. What is a zero pair? A zero pair are two terms with opposite coefficients. Two terms with opposite coefficients, and they have to be in two different equations, but assuming that these are simplified, they won't have any like terms within one equation, but they could have like terms between the two equations. So let's write out some examples of zero pairs. An example would be like an x and a negative x. Those are two terms with opposite coefficients. Maybe we should say same variable up here. That would be a zero pair. Another zero pair would be something like 3y and negative 3y. Those are exact opposites, same variable. One more example, we'll do negative 10x and 10x. So the first one can be negative, that's okay. Do we see that in problem number one? I think we do right here. The negative 8x and the 8x. And often if these are in standard form, they're going to be nicely lined up like that. All right, step two. So if you have a zero pair, all right, then add the two equations together. And we do this left to left, right to right, and we combine like terms as we go. All right, so here I'm going to erase this circle here so it doesn't get in our way. I have identified I have a zero pair, so I'm going to draw a big addition line and put a plus out way out in front here, showing that I'm adding these two equations together. So the terms on the left are going to get added to the terms on the left, the terms on the right are going to get added to the terms on the right, and we're going to combine like terms as we go. So the negative 8x and the 8x, they cancel each other out. That's 0x. We don't even have to write that. That's why this is called elimination. That's what just eliminated. 3y plus a negative 7y, well, that's a negative 4y. And 19 plus 9, that's a 28. All right, so we added everything on the left, these two terms combined, we added everything on the right, these combined, and these eliminated. An equal sign stays in the middle. All right, step 3. All right, so if we did these first two steps correctly, a variable should have eliminated, and we can finish solving for the, I'm going to say variable that didn't go away or eliminate. Finish solving for the variable that didn't go away. So there's still a y here. It's got a coefficient of -4. That -4 is multiplying the y. I undo that with an inverse operation, so I divide both sides by -4. And I get that y equals, well, 28 divided by a +4 would be 7. But a positive divided by a negative is a negative, so this is a -7. Well, I was about to box it, but we're only going to box our very final answer, so just leave it like that as we move on to step 4. Step 4, we want to plug in the value that we found into either, so it actually doesn't matter here, of the original equations. So I found that y is equal to -7, so I can plug that into either. I want to pick maybe the easier one to do. I see this has got a -7. That might be a little bit more challenging. So I'm just going to plug it into that top one, although they both look pretty similar. All right, and then I'm going to recopy it, but I'm going to include this -8x. That's not canceled out now. We want to plug it into the original before the canceling. So now I've got -8x plus 3 times y. But I'm not going to write y, I'm going to write -7 now. I can use a set of parentheses to do that substitution. All right, now I get -8x minus 21 equals 19. I guess we should write down what we're doing here. Step 5, finish solving for the remaining variable. I'll go ahead and write step 6 now as well. So step 5, finish solving for the remaining variable. Step 6, write your answer as an ordered pair. So if I got that x equals 1 and y equals 2, I would write that as 1, 2. And then that's what I'm going to box as my final answer. Okay, back to our problem. So I plugged in -7. I multiplied the 3 and the -7 to get -21. I add 21 to both sides. Then I get -8x equals 40. 19 plus 21 is 40. Divide both sides by -8. And you get positive divided by a negative is always negative, so this is going to be a -5 here. Not going to put a box around that. I'm going to write my answer as an ordered pair. And it always goes x comma y, so -5 comma -7. Ordered pair. Now I can box my final answer. All right, and let's revisit. What does this actually mean? Well, if I had graphed both of these lines, this is where they would have crossed on a coordinate plane. Or we could say this is the combination of an x and a y value that makes both of these equations true at the same time. All right, let's try that whole technique on problem number 2. So first, look and see if we've got a zero pair. We do with the 6's. I've got a negative 6y and a positive 6y. That means I can add these together. So I put a big plus out in front, big addition line underneath. All right, then I can add left to left, right to right, combining like terms as I go. 8x plus a negative 9x is a negative x. The y's cancel out. You can cross them out. I'm not going to even bother crossing them out because I need to go plug back into these equations. Negative 6 plus 12 is a positive 6. Now I can finish solving this. To get rid of that negative, I can divide both sides by negative 1. And I get that x equals negative 6. Now I've partially solved this, but I'm going to go and plug this back in to that top equation, although either equation is allowed. And in fact, if I plug it into the top equation, then I want to double check with the bottom equation. All right, so now I've got 8 times negative 6 minus 6y equals negative 6. 8 times negative 6, that's a negative 48. Minus 6y equals negative 6. Add 48 to both sides. So I'm solving for this y since it's the only variable left in my equation. And I get negative 6y equals 42. Divide by negative 6, divide by negative 6. Y equals negative 7. All right. Now that I've got a value for x and y, I can write it as an ordered pair. Always x comma y, so negative 6 comma negative 7. All right, let's just talk ourselves through the double check. I would plug in a negative 6 here for this x, a negative 7 here for this y, and make sure that I got a 12. So let's see, that's a 54 minus 42, because 7 times a negative 6 is a minus 42. So 54 minus 42 equals 12. 12 equals 12. It checks out. We have found our correct combination. All right, let's just take a look at number 3, though. Let's see, do I have a zero pair? 7x and 7x. Well, that almost looks like a zero pair, but they're not opposites. They're the same, so that doesn't count as a zero pair. 2y and negative 8y, well, that's not even close to a zero pair. And the constants can't form a zero pair because even if they were opposites, adding them together doesn't eliminate a variable. So we have no zero pair here. So we need another step. So I'll just add this as like a star. If you don't have a zero pair, comma, multiply to make one. And these are still pretty easy cases because of that identical pair. So if you have, we'll just call it a matching pair. If you have a matching pair, multiply by negative 1. So I'm going to just copy this top equation. I'm going to copy it off to the side. 7x plus 2y equals 15. But then this equation here, I'm going to multiply by a negative 1. So instead of being 7x, it's going to become a negative 7x. Instead of a negative 8y, it becomes a positive 8y. And instead of a negative 25, it becomes a positive 25. So I'm multiplying both sides by negative 1, so that equation is staying balanced. But now if we look over here, we do have a zero pair with our 7x's. The 7x and the negative 7x, if I add these together, they're going to cancel out. 2y and the 8y, those add together to be a 10y, and 15 plus 25 equals a 40. And we're off to the races. We can solve this. Divide both sides by 10. y equals 4. Plug that back in. I'll just plug it in right here because it's easier to draw an arrow to there. 7x minus 8 times 4 equals negative 25. 7x times a negative 32 equals negative 25. Add 32, add 32. 7x equals 7. Divide by 7, divide by 7. X equals 1. Now put those together into an ordered pair. Red 1 comma 4, always x comma y, and that's what we get to box as our final answer. All right, and since we plugged into the second equation, let's use that top equation to do a quick double check. 7 times 1 is 7, plus 2 times 4 is 8, so 7 plus 8 is 15, 15 equals 15, and checks out. All right, let's see which technique we need for problem number 4. Let's see, I've got a matching pair, so let me review this. If I don't have a zero pair, multiply to make a zero pair. It's maybe a little confusing. If you don't have a zero pair, multiply to make a zero pair. If you have a matching pair, multiply by negative 1. So this is a matching pair. I'm going to copy down that top equation, negative 7x minus 9y equals negative 2. And then multiply this second equation by negative 1. And that's going to flip everything. So the negative 7x becomes a positive 7x. The 4y becomes a minus 4y. And the 11 becomes a negative 11. Add it together. The y's cancel out. Combine like terms here. We get negative 13y. Combine our constants to get negative 13. Get rid of that coefficient by dividing both sides by negative 13. Y equals 1. Plug that back in wherever you want. As long as it has an x and a y, I'll plug it in right. Oh, drawing my arrow the wrong spot. I'll plug it in right here for this y, and we get negative 7x plus 4 times y, but y has been replaced with a 1 equals 11. 4 times 1, that's just 4, so negative 7x plus 4 equals 11. Minus 4 minus 4, negative 7x equals 7. Divide by negative 7, divide by negative 7. X equals positive divided by negative is always negative. So negative 1. Write our final answer as an ordered pair. Negative 1, comma 1. Put a box around that, and we're done. I believe there's some more problems in the back for you to practice. Do complete those before you turn this in, and have a good rest of your day.